are planning to retest, there's one more opportunity. It's at the beginning of power lunch today. But you had to have done all of that stuff in order to take the retest, but then we'll kind of finish that up this week. So today we just are going to kind of have like I said, a catch-up day. We need to finish talking about inequalities. We're really close. We just have a couple more problems to do. Kind of do our little graphic organizer on the next page. So you kind of have like, what did we talk about? What is an inequality? Characteristics, that type of stuff. We want to do our delta math. We want to have all the 4.1 and 4.2 done. I'm imagining that's probably at 50%, but I'm not entirely sure. And then I have some extra practice and stuff. And at the very end, we'll do a check for understanding exit ticket thing. But just kind of make sure we're like all on the same page when it comes to graphing, because it's really, really important. And then we're going to add on a little more stuff next week as we get through Unit 4. Okay? So that is the plan.
I have a question for the CFU.
Like spend the whole day practice, and then we'll just like take the CFU at the end. Okay? But just to recap, okay? So we kind of started section 4.2. I'm going to flip to this real quick. You don't have to. You can look at mine. We kind of started that last time when we talked about inequalities. We spent a whole kind of day and a half on graphing lines, plot the y-intercept, use your slope to get your other points. And then with the equations, it's pretty easy. We just draw the line through the points. But with an inequality, which remember are these symbols, less than, greater than, less than or equal to, greater than or equal to, there's a few things that change on our graph. And it has to deal with the line type. We have dashed lines and we have solid lines. Do you remember the difference between the two? What tells us? If it's connected or not, and then what tells us in the symbol whether or not we connect it or dash it. The equal to line underneath it. So remember, if it has that equal to solid line underneath, then it's a solid line on your graph. If it's just say less than or greater than, we don't equal those points on the line. We just use the dashed line from there to connect the points. And then we also have to account for the shade. Okay, so the shaded region tells us where our solutions are. And that depends on if your sign is a less than or equal to, then you're going to shade under your line. If it's a greater than or equal to, you shade above your line. So that's kind of the difference between the two. It's important because we're going to be kind of mixing all these together to really look at, is it an equation or is it an equality sign? Does it have an equal sign or does it have one of these guys? Okay, so what we did both lessons was we graphed ourselves. We wrote from graphs. So we did a couple inequality graphs for practice last time. Remember, we did our shade. We talked about where the solutions were. And then this is where we left off. We were writing from a picture. So we have this one to do. We're going to talk about how to determine if something is a solution without actually graphing. And then we're going to kind of summarize linear inequalities, and it's just practice. Okay? So look at this problem right here, this inequality. Y'all with me on that? Yes, yes? Okay, so with inequalities, we have kind of four things we need. Two of those things we need for equations. What do we have to have if we're going to write in mx plus b form? You need the slope, which is your m, and you need the y-intercept, which is b, m and b. We need that for any line that we write. Now, if we have an inequality, if we have a graph that has shade on it, we need to think about what inequality symbol should we use. So remember on this one, I kind of wrote to the side, oh, this was a solid line. The shade was below. What am I going to write for here? Dashed. This is dashed. Shade above it. Look at the shade. No, it's kind of faint here, but I think it's from the y-intercept. Looks like it's from here. We can color that in a little bit better so you can see. Our shade is which way? Which way did I go from the y-intercept? Below. Down. So you need to be able to tell, is this going to be just an equation or just an inequality? If there's shade on the graph, it's going to be an inequality. Okay? So what symbol do I need to use if I have a dashed line with shade below?
The regular, not the line.
Not the line on the bottom. We'll take care of the dashed, and then the shade below means I need to have a less than. So that means right here, I can go ahead and start this, y less than. So there's just a little more thinking you got to do with those inequalities to figure out which symbol that does need to be, okay? And then here we are again for literally 3 weeks now. finding the y-intercept, finding the slope. Like, that is still the same thing we've been doing. What is the y-intercept of this graph? -1, so that's our B, -1. We need another good point, another perfect point. Does 1, 2 look pretty perfect to y'all? 1, 2? I think that looks pretty perfect there. Okay, so we need to slope that. So we have 0, -1, and we have 1, 2. You can slope formula that, or remember, we did talk about this when we were graphing. That slope is you're changing your y and you're changing your x. Y'all ever count? I know I've seen some of y'all do that. Did y'all ever count from point to point? It's kind of a shortcut. I'm okay if we've done so much slope formula. I'm okay if we kind of shortcut this. So if I want to start at my bottom point and I want to get to this point, what was my change in y? 1, 2, 3? You see how I did? I went up 3. So I would put change in y was +3. What was my change in x? 1. What is 3 over 1 reduced to? 3. And so my slope would be 3. Okay, if you do it like that, I'm okay. You can always go back to the formula, but we've talked about this a lot. And again, that's you got to count your vertical change in y, change in x. Another thing, be careful with this because sometimes people get negatives wrong. But is this line going up or down? Up. So I know my slope has got to be positive. Sometimes I write in that sign first. Like I know this guy's positive. You don't really have to put a positive sign there, but if it was negative, I would go ahead and put a big negative in front. And then I would do my counting from that. So my slope is +3, so I can do 3x, my y-intercept, -1. Okay? And that's my inequality. We have to be able to find those slopes and those y-intercepts, and then with inequalities, we've got to determine the symbol. Okay, write an ordered pair that is in the solution set. Little game real quick before you write down. I'm going to point.
Area, right?
Yes. I'm going to point to points and I want to tell me solution or not. Okay, ready? Watch my pen. Solution or not?
No.
Why not?
Because it's not in the shade.
Not in the shade. Solution or not?
Yes. Because it's in the shade. Yes.
Yes.
No.
Yes. Oh, no.
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 Why?
Because it's not
On
in
the
the
line.
shade.
It's a dotted line.
Very good. Very, very good. Okay, so now you can pick some of the points I just made or pick your own. Pick one that is in the solution set. The only ones in the solution set are going to be in the shade, not on the line. Any point that's not on the solution set, no shade or on dashed line. So multiple correct answers here. Feeling pretty good about these inequalities. I'm starting to feel good about this too. I think it's just kind of, again, puts it all together. Okay, so the next two questions, we're going to put a star on these because you're going to see them again. Star, star. We'll do one together and then I'll let you guys try one on your own. So this one says without graphing, okay? How do you know if this is a solution? All right, we can't graph. Y'all been great at telling me if stuff is a solution with a graph because you just look at where the shade is. This one says without graphing. So what do we do? What do we do? Well, what do we have? We have a point, right? Y'all see the point we have? Okay. When you have a point, what kind of values do you have? You have an x and you have a y, right? Write that down. Might be helpful. Do we have an inequality right here? And in that inequality, do we have a variable x and a variable y?
Yep.
Is this inequality in slope-intercept form?
Yep.
Yes.
mx plus b? Is this in mx plus b form?
And y equals? Y inequality?
No, this is not slope-intercept form. Okay? So we can't look at that there. We're going to talk more about the forms next week, but this is not slope-intercept form. But based on what we know, we have an x and we have a y that goes with it. We have an inequality that has an x and a y. So what do you think we should do?
Substitute it.
Sub them in. Okay? So I can put, where I see an x, I'm going to replace it with a 2. Write this with me. Where I have a y, I'm going to replace it with a, and notice what I put those two numbers inside of. Parentheses. So kind of like when we were evaluating functions last time. With that idea, this time we're plugging in an x and a y, an input and an output. But if it is a solution, when I evaluate what this is, I'm checking to see if this number is greater than -1. I'm going to put a question mark. Now, if the number that I get over here when I evaluate is greater than 1, then that means I have a true statement. So what does that tell you about the point? If it's true, then is it in the solution?
Yeah.
Yes. If it's false, is it in the solution?
No.
No. So that's the idea, is you don't have a graph, what can you do? Plug them in. Okay, and you could do that up here as well with the ones in slope-intercept form. I think it's quicker if you have a graph, but I've seen some STAR questions where they take away the graph, and then they kind of want you to do this. So let's put this side that I underlined, the side with the parentheses. We can throw that in our calculator. We can find that value. 3 times 2 plus -4. Okay, and I'm just writing it exactly as I typed it. I cannot type the inequality. I'm strictly doing the left-hand side. And that's going to give me a value. We're evaluating. What value is that?
2.
Did y'all get 2? We need calculators here, people. Got a value of 2. And then again, go back to your question. Your question is 2 greater than -1? True or false?
True.
That is true. So what does that mean? Yes. 2 -4 is a solution. True statements mean they are solutions. Okay? False statements mean they are not. You are going to have to do this on your test. It's not hard. You just got to know what to do. So test the other one. You guys test this one. You finished? Okay, what value did you guys plug it in the right way?
Yeah.
Okay, I like to label my points. Again, this is my x, this is my y, so I know where they go. Okay, and you could do this even if it was in slope-intercept form. Even if it wasn't a different form. We might try one for the problem above. All right, 1, 4, when I plug that in, what is 3 times 1 plus 2 times 4? What number is that? 11. Okay, so is 11 less than 11? No. Okay, now if they have the equal to, would that be a solution?
Yes.
But we don't have an equal to, so is this a solution? No, so false is what I think. My actual answer, make sure you know what your answer is. My actual answer is no. 1, 4 is not a solution. Okay, because you got a false statement. Let's try one in slope-intercept form real quick. We'll find some space. Let's find some space on the back. Let's do this inequality, okay? Y is less than 3x minus 1. Just right here. We'll do a little extra practice. Y is less than 3x minus 1, okay? And let's test, we'll test a point that was in the, or y'all give me a point. Let's just pick a point. Miles, pick a point. Pick an x, pick a y. 2 for x, like 2 is your x value, okay?
And then for y, I do
Pick a negative.
-4.
-4, okay? We're going to see if this, without graphing, all right? So is this guy in slope-intercept form?
No. Yes.
Yes, y is all by itself. But it's the same idea. I have an x value. I have a y value. It's going to look a little bit different, though, when we plug in, because this time x and y aren't on the same side. But it's still the true or false game. So what am I plugging in for y?
4.
What kind?
-4.
-4. So my question is -4 less than 3? There's an x. What am I plugging in for x? 2 minus 1. Question mark. I always like to put a question mark on that because I don't know. I'm trying to figure it out. Okay? Do I need to do anything with -4 on this side? Any math? No, it's just a number. -4. Write it down. All right, what about this? 3 times 2 minus 1. You can probably do this in your head. 3 times 2 is? 6 minus 1 is? 5. True or false? Is negative 4, what does that symbol say? Less than, sideways L. Is negative 4 less than 5?
Yes.
So is this a solution?
Yes.
Yes. Okay, so it doesn't matter what form it's in. If you don't have a graph, if you just have a point and you have an inequality, no matter what it looks like, just plug those guys in and look and see if it is true or false. Okay? Again, when you have a graph, it's a lot easier to do because you just look at the point, but we want to know how to do it algebraically as well. All right, this is our linear inequalities. Remember, these are y, and then I'm going to put a symbol, mx plus b. Remember, in that symbol, we can have, what are our 4 options?
Less than, greater than.
Less than, greater than.
Less than, equal to, greater than.
Those are all the symbols we can have. Okay, but we're talking about these in slope-intercept form right now. I want you to write down, do y'all want help with the definition?
Yeah.
Okay, we'll do the definition. So our inequalities are, I'm going to copy what I have over here. A mathematical sentence using inequalities to determine the solution set. That's very proper. A mathematical sentence. Is there an E in there? Yeah, okay, that's what I thought. To determine, I'm just going to do this box with you and y'all are going to do the rest. To determine the solution set. Solution set of an inequality. So you fill out your characteristics. Again, those are like things that we need. What do we need to know?
X and Y.
Those are
Or
things
X.
you can find.
Yeah,
But what?
or X and a pretty one. I don't know.
I don't know. What do we always find? Look back at your notes. What do we find? What do we have to check for? What types of lines can we have? What types of shades? So kind of fill these out. Do 2 examples. Give me 2 examples of linear inequalities. Give me 1 not example of a linear inequality. Answer the little boxes. And then we're going to check with your table in a minute. See what you got. And for the rest of the day, we need to, before we leave, we are all going to be all the way through 4.1. Most of you are. Some of you are not there. Some of you are at 0. Some of you are close, but we're going to complete 4.1 and 4.2. Now, there's a couple sections on 4.2. There's 3, and then there's 4 individuals. Stop at 4.3. I don't know what that percentage is. Someone who gets there can tell me. But we need to get through 4.1 and 4.2. When we finish that, I have some extra practice sheets that you can work on. 1 for equations, 1 for inequalities. And then we're going to exit ticket, I don't know, last 20 minutes. Okay? So that is the goal, is we want to get all the way caught up. 4.1, 4.2. Everyone got it? Ready, go.